it just killed itself. It was very weird. I don't know why.
Maybe it was full again.
It could have been. I don't know. That was really weird too. I didn't know it was saving it in 2 different places. Now that I know that, I can delete it. All right. So today we're going to talk about bonds. Sounds like lots of fun.
Does it?
It does. It sounds like loads of fun. So to motivate what we're doing in this particular section, let's just look at this problem. So there's lots of words in here. So we need to go through and talk about what we're talking about with these things. So you've got a $1,000 par value bond with a term of 5 years, a coupon rate of 6% payable semi-annually, and it's purchased to yield 8% convertible semi-annually. So like I said, lots of words. All right, so the yielding 8% convertible semi-annually, that's stuff we've done, right? That's not any other issue. That's telling us that we would need to divide the interest rate in half first to start with to get the semi-annual rate no matter what we're doing. Right? So that part's not the hard part. So the harder part, and it really isn't all that hard, are these other words that we have in here. So when you have a bond, you have a par value or a face value. Okay, so that was the first part. The par value or the face value is what the coupons are based off of. Okay? So the idea behind a bond is the following. You need money to, I don't know, build a new theater building, say, or a university commons, whatever. So you want the money, you might have pledges already for that money, but you don't have that money right now. So what you want to do then is you want to borrow money from people, wherever those people happen to be. You could go to the bank and ask them for money. But a more common way to do this is to do this with bonds. So you're going to go sell these bonds. School districts do this, universities do this, large corporations do this. Large corporations definitely do this because they don't want to necessarily raise capital by issuing more stock, because then that dilutes the ownership of the company among more people. That is one way to raise capital, is to sell more stock, issue more stock, sell more stock, but that also dilutes your ownership. So another way is to sell bonds. It gets you money quickly, but then of course you have to pay interest on it. So basically what it is you're going to issue these bonds. They're going to give you a certain amount of money for this bond. So what you're going to be making payments on these bonds are coupons. Coupons are just interest payments. Like I said, this FM exam is more vocabulary exam than anything. Coupon payments are just interest payments. Okay? So the coupons, the interest payments, are based on the par value. Okay? Now notice that this coupon rate also says 6% semi-annually. So much like what we do with the yield rate, when we say it's convertible semi-annually, we have it and then apply it every semi-annual period. The same thing happens here with bonds. Those coupons, when we calculate the coupons, they're going to be payable every 6 months, semi-annually. And to calculate the coupon amount, we're going to take half of the coupon rate, and that's going to be and multiply it by the par value. So in this case, it would be $30. 3% of 1,000. That make sense? All right. So it asks us to find the purchase price. Well, the purchase price means the amount that you're going to pay out now. So the purchase price must be the present value of these things. So you're going to have this payment stream coming in of your coupons, plus at the very, very end, you're going to get your money back that you invested. Okay? So for this particular setup, we're not going to write it out this way every time, but for this particular setup, you're going to get 9 payments of 30.
Where's the 9?
And can I say the last thing and I'll tell you?
Yeah.
Okay. And then one more payment of 30 plus your original $1,000. So 10 total payments. Why is it 10 total payments? Semi-annually for 5 years. That was where the 9 came from. Okay. So it's semi-annually for 10 years. So you're going to get 9 payments of 30, and then a final payment of 1030. So we've got this payment stream coming in, but we should be able to figure out this present value, correct? So if you guys notice, I can really break it into 2 parts. I've got a level annuity of 30, and then a present value of a lump sum at time 10. Well, time 5, but 10 semi-annual periods. So the price of this bond should be the 1,000 times v to the 10th, right? Because the 1,000 comes at time, the 10th semi-annual period, and then plus 30 A angle 10 at 0.04. So that would be how we would, notice that this bond problem isn't any different really than any other problem that we've been doing, right? It's the same concept, isn't it? We've got a present value of a lump sum, a present value of an annuity stream. Same concept. So we can use our and I'll show you how to do this in the calculator in just one step, just using our time value of money function. But if we look at the format of the formula, this part right here, by the way, I use this as the par value or the face value. In this problem, they didn't tell you that it was different. In some problems, what you get at the end might be different than the amount that you get your interest payments off of. Okay? What I mean is that you might have a $1,000 par value bond, for example, but at the end, your redemption value, what you'll get back is $1,100. It might be a different amount. The par value is what you compute the coupons on. The par value or the face value is what you compute the coupons on, the interest payments on. The redemption value is the lump sum that you get at the end. Now again, in most of the problems, those 2 values will be the same. Your par value and your redemption value will be the same, but it doesn't have to be. Okay? So, if we look at a general formula idea here, the formula looks like the price will be C, a lot of the books use C times V to the N, where C is the redemption value.
Just to clarify, that's how much you get back at the end.
That's how much you get back at the end, right? Yep. Now again, like I said, in most problems, it's going to be the same as the par value.
What's the difference, or what's the par value?
The par value is what you actually compute the interest payments on. So even if the redemption value is $1,100, if it says it's a $1,000 par value or a $1,000 face value, then your coupons are based off the 1,000, not the 1,100. And then we'll have plus F times R, and then I'll say A angle NI. So the F here is your face value or the par value. The R is your coupon rate per period. And your I is your yield rate per period. And I just realized that I didn't give you the handout with the problem on it. Sorry about that. Yeah.
I like my calculator working by the way.
What's that?
So I got my calculator.
What did you do? What did you do? Just smack it around a little bit?
Hard reset on it.
Oh.
Yeah.
Well, one way to do it. All right, so this problem is the very first problem in that handout that I just gave you. All right, so that's the formula for doing this. is. Let's see how we would do this with the calculator. All right, so we can use our time value of money buttons to do this on the calculator, just like we have the other things. Oops, cleared. Okay. All right, so what we want to calculate is the present value. That's the money that we're going to be laying out to get back this income stream plus future value, right? So for this particular problem, we're going to put in 30 for the payment and 1,000 for the future value, both with the same sign, because you're going to get those monies coming to you, right? If you're the investor, you're going to lay out whatever the purchase price is, and that's what you're going to get back. So those will have the same sign, okay? So I don't need to worry about those having opposite signs in this case. So you'll put 30 in for the payment and 1,000 in for the future value. And then we'll put in the other pieces here in a second. So let's do that. Maybe here you go. You're welcome. All right. So the future value is 1,000, and the future. Whenever you're going to put in here for the future value, by the way, that's going to be your redemption value. So if your redemption value is different than the future value, put the if your redemption value is different from the par value, put the redemption value in the future value. Because that's what you're going to be getting back at the end. Okay? All right. Your coupon payments in this case were 30. Again, remember the coupon payments are based off of the face value, the par value. The yield rate was 4 in this case, because that was 8% convertible semi-annually. There are 10 total periods, so that goes in for N. Because there's 10 total semi-annual periods in the 5 years. And now let's compute the present value. And we get 918.90. At least that's what I got. Is that what you got?
Yeah.
Okay. All right. So the price here in this case is 918.90. All right. So the first thing that we notice is that the price here is lower than the redemption value. We're lower than the face value, right? So we say that we get this bond at a discount. It's a discounted bond because we paid less than the par value. So it's a discount. Now let's think about why we paid less. Okay? What's the coupon rate? 6% each convertible semi-annually, right? What was the yield rate? 8% convertible semi-annually, right? So, or if you go per period, it was 4% per semi-annual period versus 3% for the coupon rate, right? So what does that mean from an investor standpoint? If the yield rate is 8% convertible semi-annually, that means I should be able to take that $1,000 and go put it in the bank and make 8%, right? But if I go buy this bond, what am I going to make instead? 2% less, 6%, right? So am I going to pay $1,000 for something that's going to give me less money? No, I want to pay less. That's why we get a discount. Okay. Now the other way around, if your yield rate is less than your coupon rate, if the coupons pay more than the prevailing market rate, you would expect to pay more for the bond because you're getting a better return. So in that case, you would be paying at a premium because you're paying more to get the higher interest rate. That make sense? Okay. All right. But this is how prices are calculated for bonds, especially when they're traded day to day. You're looking at the prevailing market rate, looking at the coupon rate, and calculating the price for each particular day, whether that happens to be when you trade these bonds. Okay. All right, so just to write this down, if your coupon rate is less than your yield rate, then we have a discount for your bond. And the discount again means the price is less than the par value or the face value. The other way around, you'll have a premium, and which means the price is greater than the par value. I'm saying this, by the way, for redemption values that are equal to the par values. It's possible, well, you can still do discount and premium based off of your redemption value as well, if you're paying less or more than what you think you're going to be getting back. We usually use these terms just for bonds that are redeemable at par or at their face values, and not for some different redemption values. Usually we worry about discounts and premiums for par valued bonds. Was the concept of finding the price okay? This idea here, where we did the present value of the redemption value and then the present value of the coupon payments?
So redemption value is called C.
The redemption value is C. Yeah, that's just what most of the manuals use as a C for redemption value. I do not know why.
And then the coupon rate is F.
The coupon rate is R. The F is the face value or the par value.
Oh.
All right. So sometimes it's helpful to write this formula in a slightly different form. So to do that, let's say that your bond is redeemable at par. So your C is equal to F. Okay? So this part right here, this says that the C is equal to the F, right? Well, we can rearrange some things. In particular, I want to try to rearrange some stuff here that combines terms that involves the present value of an annuity. Wow, that really does make your head swim if you're paying attention to this thing shaking if you're close to it. So this, I want to see this present value of an annuity in this first formula. So what is the formula for A angle N? What is that formula? 1 minus v to the n over I, right? Which isn't quite what I have here, right? So to get that, let's see what I would have to do. Let's just do a little bit of playing with the algebra. Well, I want a minus v to the n, right? If I want to see A angle N, I need a minus v to the n, right? We agree? Okay. Well, that means I better have a negative 1 to match those things up, correct? We agree? Okay. I need a 1 minus v to the n, which means I better put a plus 1 to even that out. If I think about this minus still being in front here, right? This is a minus, if I do it this way, that's a minus 1, correct? Yeah. And then if I put this over I need to adjust with an I here, don't I? I'm just playing with the algebra is all I'm doing, right? I'm trying to see 1 minus v to the n over I. I start with v to the n. The first thing I did was what? Made it negative. I want to make it negative, I better make it positive again to keep everything equal, correct? All right? I need 1 minus v to the n. If I put it inside these parentheses, I'm subtracting 1. Correct? So I need to add 1 on the end. And then if I need it over I need an I on top to keep everything equal. Right? Now again, my whole motivation for that, which doesn't seem like it's a very good motivation, but my whole motivation for that is to see this A angle N piece here, right? If we rearrange this algebraically, you get face value, par value, plus face value times R minus I times A angle N I.
How do you do that?
What did you just do?
What did I do? I'm magic. I'm a mathemagician. That's A angle NI, right? So this is minus FI A angle N. So I moved it over here and factored it out. Everybody's looking at me like I'm nuts.
No, I
No, I see it.
Oh, okay. This F, I distributed the F to here and to here, right? So there's just an F there. This is A angle N times a negative Fi. So I just moved it over here and factored out the F and the A angle N. Right? So notice here, one of the reasons why we do this is that I notice that this piece here really is a premium or a discount piece here, right? Here's my face value. This part here is the difference between the coupon rate and the interest rate. So this part here is the present value of this premium of the coupons. So we can do what's referred to as amortization of the premium or the discount, and look at the amount of premium and amount of principal and amount of interest, amount of premium or an amount of interest in each of the payments. Like we did when we did the principal and interest for amortization of loans. All right? This book value, the price, what is also called the book value. There's lots of words that go with bonds. This price is payment. As you start getting the interest payments, the price goes up because you're getting closer to that $1,000 at the end, right? Every single coupon payment that you get, the price of the bond goes up because it's getting closer and closer and closer to that $1,000. What that means is that if you are the owner of that bond, you have an asset. That asset has a market value that you're going to be reporting on balance sheets. Okay? You need to know what the value of that bond is at that instant that you're making the balance sheet. Okay? So when you do this amortization table, it's telling you what the value of your bonds are going to be over time. If you're looking at valuing your company in any particular, if you're a company that has the bonds, owns the bonds, you're looking at your value of your company in any particular time. That's the idea. Next thing.
So the present value, or the one we found, the 119,890, that's at like times 0, right?
Mm-hmm.
So that means like when you make the balance sheet, like would you want to say like we're in this year, or like we're at this day, or we're at this second? Like is it continuous, or is it to the day? Or
You can do it to the day, typically, is what it'll be computed to. We're going to actually allude to that here in a little. I don't know if it'll be today or Wednesday, but we'll talk about it. But yeah, so when you're on the balance sheet, it'll have it whatever that day is, whatever the value of that bond is at that time, whatever the market price of the bond is. There's actually a difference between, if you're in between coupon payments, there's actually a difference between what the market price for the bond is and what you would actually pay for the bond is. The reason for that is if you're in between coupon dates, say you're halfway in between when coupons should be distributed. Well, if you're the owner of the bond, you should expect half of that coupon, right? But it doesn't actually get distributed till the next one, right? So whoever buys the bond is going to have to pay extra because they're going to get the lump sum of whatever the coupon payment is at the end, even though you should have been entitled to half of it to start with. So we have to adjust for the price based on where we are in the time period for buying the bond. So that actually comes up too. But when you're actually writing things down on a balance sheet, you're not necessarily assuming that you're selling it, so you're not going to put that piece into your balance sheet. Where if you were to sell it, then you would have to worry about how much the interest payment is in there. We'll talk about that when we get to it. I'm more interested in just getting the prices right now. This one okay? I said a lot of words. There are a lot of words that are involved with bonds. So let's look at the next one. You notice for Haley, I just labeled my pages too. Makes Haley feel better.
It does.
All right. So look at this one. What do you think we would do?
Use that formula.
Okay. So we could write it down with the formula. If we're going to write it down with the formula, what would it look like?
975.
Okay.
75 equals 1,000.
Okay. Okay.
Plus, also, yeah, 1,000.
Okay.
Would be 23.
Okay.
And the annual 10.
Good. Oops. Make it a little bit right. That would be the formula, right? That's exactly what it would look like. The challenge with this one is what, though? What are we trying to solve for? I, which is typically difficult, correct? The reason why is because we've got that 1 over 1 plus I to the 10th in 2 places, and then an extra I in the denominator. Right? When we think about the formula for the A angle 10. So this is the correct formula. It's just that this would be really, 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 really hard to solve by hand. And by really, really, really hard, I mean impossible to solve by hand.
Multiple choice.
What's that?
Unless you have multiple choice.
Unless you have multiple choice, true. Instead, what do you think we want to use?
The new formula we created.
I mean, I'll still have the same issue, though, because I'm still going to have V to the N of the I. Oh, I like the calculator. That sounds like a good idea. Well, it sounds like a really good idea if I get the calculator to come up. There it is. All right. So what goes in for the pieces?
N is 10.
Okay. I was trying to move this out of the way. Let's move this up. Not you.
What number are we on?
I think it's 2.
No.
All right. N is 10. I agree with you.
Payment is 30.
Payment is 30. I agree with that.
PV is 970.
975.
That does be negative.
Good. Yes, it does. Because we're laying out $975 to be able to get back these payments. So their present value has to have an opposite sign from your payment and your future value. What are we going to use for future value?
1,000.
Good. 1,000, not 10,000. And then compute.
You said not 10,000 and I typed it out. 10,000.
Oh, good. And then compute our interest rate and get almost 3.3.
It's the sine of 2 to the 50.
Do we have to multiply that by 2?
Why? Good. So this is what we just computed here is a semi-annual rate, right? Because we put 10 periods in, that's 10 semi-annual periods. So we got a semi-annual rate. Now notice it's asking for nominal convertible semi-annually, right? So we just need to multiply it by 2. We do not need to do 1 plus it and square it and then subtract 1. That would be effective, right? It's only asking for nominal, so we just need to multiply it by 2. Does that make sense? We okay with that? All right. Questions on that at all?
So then it's still a discounted bond?
Yes, it would still be discounted because it was less, right? Which makes sense because the interest rate that we came up with should be less than the coupon rate that was there.
Should be less than.
It should be greater than. The interest rate should be greater than because that was what we had a discount. Your coupon rate should be less. This is what it was in this case. All right, let's look at 4.8 is on the back. Let's see, I think it's on just if you flip, it should be the next page. 4.8. Okay. Not the back side, but just literally just flip the page. It should be 4.8.
Not the
Yeah,
back.
yeah, not the back, I just literally just flipped the page.
Yeah.
All right. So the first thing we want to do in this problem is, well, I want to show you something with the calculator. We don't really need the calculator for this particular one, but I want to show you with the calculator anything. Anyway, so the first thing that I want to do is get everything into the calculator. And then I'll show you what the form, what it's asking you to do for the interest portion. Okay. So get the stuff in your calculator. Get your, in this case, price computed, because that's the thing we don't know, right? We know future value. We know coupon. We know interest rate. Now notice in this case it's annual coupons rather than semi-annual. So we don't worry about, try again. We do not need to worry about dividing anything in half or anything. Marshall, I'm enjoying your double fisting the calculators.
No, I can. My calculator works.
Yeah, because your calculator works.
Got everything and stuff.
I got the price negative 14 or negative 11,472.
Okay. Great, did you get that? You get there.
I gotta write it down.
Okay.
That's good.
Did you get that?
Yeah.
Okay.
Dr. Joe, how are you wearing shorts today? It's snowing outside.
Have you ever? How often have you seen me without shorts?
The
That's
last,
fair.
I saw you twice.
You did see me twice in the last week without shorts. That is true.
We're very dressed up.
For me, that was very dressed up. That is correct. If you see me later this evening, you'll see me in long pants again because there's a economics candidate on campus and I'm way to north tonight.
So
So
what did you guys get for the prime time?
11,000
11,472.
I have 17,000. Yeah, but do you have for your future value? It's fine. If you have repayment.
800.
Negative.
Your interest?
No, the payment was
You put in for your
positive.
payment, right?
Is the future value was positive?
no, it's 8% coupons.
That's okay.
Well, you just put it in as-
That's what it was.
So 800.
800? Jesus.
Way to
that's
go,
definitely
Marshall.
not-
That was definitely why you had such a big number.
Save me.
No.
Because you were doing 30%. You were doing 30% coupons. That's a big coupon.
What's our
I also got
rate? 6% annual rate?
6% annual rate. Yep. And it's annual coupons.
And there's 10 years.
You got that. Okay, now I'm there.
Now you're there. Sweet. All right. So you would put in 10,000 for your future value, 800 for your coupon, 6% interest rate for 10 years. I forgot how many years there were. Compute present value, 11,472. Okay. So remember that we had formulas for calculating amount of principal and amount of interest in a payment, right? We could also do that on the calculator as well. You can do the same thing here. If I go into the amortization worksheet, so second amort, whatever. Sounds better when Kelly says it anyway. So we want the 7th coupon, so we'll change P1 and P2 to 7. There's, by the way, it tells you what the balance is. What this means is that after the 7th coupon is made, you would have 3 coupons left, so this is what you would pay, assuming the same coupons, the same interest rate. So that's your market value of the bond at time 7. Okay, so you can find that on here too. If I scroll down, you'll see similar things. Notice in this case, we would pay more for the bond than what the bond's value is, the bond's par value is. So that's a premium. So what this does is it amortizes the premium over time. You paid a certain amount over the 10,000. You're doing amortization on the premium. So the extra amount that you paid on the bond. So the amount of principal or the amount of premium in the 7th coupon is the 158. That's how much of the coupon is actually what you paid extra and not getting interest on. So it's not, the whole point of this is that you're getting money back that you paid extra. It's not interest income. That 158, even though you're getting an $800 payment, that's not interest income because you paid extra to get those payments. So you can take off the 158 for a tax deduction. Now we're not doing tax accounting here. You don't have to worry about that. That's the whole reason why we're worried about it, or why we're even talking about it. If you needed a tax deduction, that $800 that you get in, if you can't amortize your premium, you're going to be paying taxes on that whole $800. But since you paid a premium for this bond, that $800 isn't all income. A portion of that is money you got back. Okay? So that, in this case, it's $158. The amount of interest then, well, I could do subtraction, but of course we know that if I just scroll down, I can get the amount of interest. So it would be the 642. That makes sense?
So, you're getting back the 158?
You're getting an $800 payment. Okay? Regardless, because you're getting these $800 good Lord. You are getting these $800 coupons. That wasn't even trying to say amortization. You're getting these $800 coupons. However, to get this $800 coupons, you paid extra. You didn't pay $10,000 for the right to get this money. You paid $11,472 and change, right? So of that $800 is $158 coming back to you of your original money that you didn't earn any interest on, that you paid extra to get these payments, and then the rest is interest. So when you're claiming this on an income statement, you're only going to claim $642 of interest income, not $800 of interest income. So it saves you taxes. That's the point of doing this. Now think about doing this for multiple bonds with multiple coupon rates and multiple yield rates flying all around the place. That's what computers are for. They have all this stuff built in. But that's why we care.
Question.
Yeah.
So this would work if it was a premium, right? Or does it work?
Yeah, it works if it's a discount too. Yeah, you just have negative amortization in that case. What that means is that you actually have to claim more in interest than what you pay. Your amount of principal or amount of discount will be a negative amount. So say in this case you paid $9,000 instead of $10,000, so you have this extra $1,000. So maybe in this payment you get an $800 payment, but really $870 of it's interest. And then because you're doing negative amortization on your discount that you got. Because you're getting more back than you should have if you would have laid out $10,000 to start with.
So you pay more tax?
Yeah, you pay more taxes on that. Because you got a higher amount of interest back. Yeah. Which again is why it's important to keep track of these things, because if you don't pay enough taxes, then you're going to have all sorts of people in places where you don't want them. So yeah, you have to worry about that too. So that's actually referred to as negative amortization because you're amortizing money that you didn't pay, that you're going to have to pay interest on because you're getting extra money back. I know it's weird. But that's the idea. We okay with this? All right. So you can use the same formulas that we used before because you'll know the amount of premium that you pay, right? How much premium that you had. and what the coupons are, and you can still use the same formulas that we did for payment times v to the n minus t plus 1. Those formulas still work. It's the same amortization principles that we did for loans. So it's the same formulas. So next time we'll do some more problems. We will talk about 2 more things. One of them is callable bonds. You know how when you do amortization, you don't get any penalty for paying something off early, right? You can actually try it. One of the things one of your homework problems asks you to say, okay, I'm going to pay this back after the 50th payment rather than waiting for 120. That was one of the homework problems, right? Okay. So you don't get any. The advantage of that is to pay it off early. With callable bonds, if the bond isn't callable, then the person who bought the bond can expect coupon payments at those prescribed times until the term of the bond. What a callable bond means, it'll set a time at which you can start paying it off and not have to pay any more coupon payments afterwards. So maybe you have a 10-year bond, but you make it callable after 7 years if you want to try to pay it off early and save you some interest payments. So what we'll talk about is how do you price these callable bonds. Spoiler alert, you're going to pay the least amount possible. Shocking. So it depends on whether or not it's at a discount or a premium for what you use for the term for the price. It's not that bad. The other thing we're going to talk about is what happens if you sell a bond between coupon payments. How do you price it? So those are the 2 things that we'll talk about on Wednesday. We will not have class Friday because I'm going to a conference. So you're going to get another Friday off.
Okay.
Anyway, so let you know.
We have our test next week.
The test in here is the following week. Quick, how are we going? I don't have time to do another problem. So.
Did you just get out early?
12:50.
Yeah, we gotta go.
For him, that's early.
Yeah.
All right, see you later, Dr.
Hey, Grace. Don't fall in the snow.
Come on back.